2017 Differential Calculus, question 10a. A particle starts from rest and moves in a straight line with acceleration 25 minus 10v meters per second squared, where v is the speed of the particle. After time t, find v in terms of t, and they always give us this note. Let's do a quick rehash of these velocities and speeds and distances. S is equal to ut plus a half at squared. ds dt is equal to u plus, I left out squared, u plus at, which we know is equal to velocity. So velocity is ds dt. Now if we differentiate this again, if we have v is equal to u plus at, and we differentiate velocity with respect to time, we're going to get acceleration. Because u is a constant and at just becomes a, like 5x becomes x. And we're told here this acceleration is 25. A is equal to 25 minus 10v. And we can change our a now into dv dt. So the connection between these formulas that you've used in linear motion and other areas of the course. So dv dt is equal to 25 minus 10v. We want the v on its own, so we're going to divide by 25 minus 10v and multiply by dt. So dv over 25 minus 10v is equal to dt, and that's what we're setting up here, this equation. So we're going to integrate both sides now. And we're going to integrate between the particle starts from rest, so it's between v and 0 and t and 0. And we know I'm going to shift the t to the left. That's just going to give me t minus 0, or t is equal to, here's my b. So your b in this case is your minus 10. So we're going to get this 1 over minus 10. So we're going to get a minus 1 over 10 by the natural log of the bottom. You can see a plus bx, a plus bx. Now the c is not going to be necessary, because if we put the c in, it'll just cancel out when we do both parts of the integration. So we're just going to get 25 minus 10v, and that's between v and 0. So we put our v in and our 0 in, and we're going to get t is equal to minus 1 over 10 by the natural log of 25 minus 10, and we're putting v in first, so 10v. And then it's going to be minus minus, so we're going to get a plus 1 over 10 by the natural log of, we're putting 0 in here, so we're just going to get the natural log of 25. Now if we reverse these around, so we can get a division of two logs, it's 1 over 10, or we could multiply, but let's multiply by the 10 first, it'll be easier. So then we're just going to get the natural log of 25 minus the natural log of 25 minus 10v. That's division of logs, so natural log of 25 over 25 minus 10v is equal to 10t. So we know we need to get rid of the natural log, we need to raise the other side. E to the power of 10t is going to be equal to 25 over 25 minus 10v. We want to solve for v here, so let's multiply across by 25 minus 10v. 25 minus 10v by e to the power of 10t is equal to 25. You divide across by 10 here, you can see the v will be on its own, its bracket. Let's multiply it out first. 25 e to the power of 10t minus 10v by e to the power of 10t is equal to 25. So 25 minus 25 e to the power of 10t is equal to, well, I should reverse that around, minus 10v e to the power of 10t. If I divide across by minus 10, I'm going to get v e to the power of 10t is equal to minus 2.5 plus 2.5 e to the power of 10t. Now I need to divide across by e to the power of 10t, so I'm going to get v is equal to minus 2.5 over e to the power of 10t plus 2.5. And if I reverse those two around on the right, I'm going to get v is equal to 2.5 minus 2.5 e to the power of minus 10t. We need to bring it up. So I can factor out a 2.5, which would leave me with minus 1 minus e to the power of minus 10t. And that's equal to v. Part 2 asks us to find the time taken to acquire a speed of 2.25 meters per second. And then find the distance traveled in this time. Okay, but to get distance, we need to integrate velocity. We saw that up above, didn't we? So to go from velocity backwards, we need to integrate. So we can integrate the velocity to get the distance. And we actually have an equation here for time as well. So let's use this equation for time. We have it in terms of t, and it's just calculator use. So I'll do it here. Time is equal to minus 1 over 10, and we're told that the speed is 2.25, so the natural log of 25 minus 10 by 2.25 is 22.5. V is equal to 2.25, and then I'll just write it underneath plus 1 over 10 by the natural log of 25. So let's type these two things into our calculator and get time. Time is equal to, so using our calculator we get 0.2302, so 0.23, time is 0.23 seconds. And now the second part, we need to integrate, so the time taken is 0.23. We want to get the distance, so we need to integrate the velocity. So we set that up. We want to get distance. So we have ds dt is equal to v. Write that down to begin. ds dt is velocity from up above. We saw that at the beginning. So we want to integrate ds, and that's going to be the integral of v dt. So we integrate s between s and 0, or ds. We're going to get s minus 0, or just s. And that's going to be the integral between at the start and how long does it take to get to 0.23 seconds, or what speed or the distance we're going to travel in that time. We need to integrate v, which we have up above here, 2.5 minus 2.5 e to the power of minus 10t dt, and that's going to give us s is equal to, if we integrate 2.5, we're going to get 2.5t e to the power of at, so that's going to be my minus 1 over 10, and it's a minus in the middle, so it's going to give me plus 1 over 10 by 2.5 e to the power of minus 10t, and it's between 0 and 0.23. So we get 2.5t. I'll just tidy it up first. 2.5 divided by 10 is 0.25 plus 0.25 e to the power of minus 10t. And if I put my values in, I'm going to get s is equal to 2.5 by 0.23 plus 0.25 by e to the power of minus 10 by 0.23. A bit more room here, and then minus 2.5 by 0, so we can put that in if you want to see it. 2.5 by 0 plus 0.25 e to the power of 0. So that will give us s is equal to 2.5 by 0.23, which is 0.575, plus 0.25 e to the power of minus 2.3. So 0.025, and then minus by a plus is going to give me a minus, and we have 0.25 e to the power of 0, it's just minus 0.25. And simplifying this, we're going to get the distance traveled in that interval is going to be 0.35 meters.